Right, let's go then. So, 3 examples to copy down. First one, 3/4 plus 1/3. Okay? Very bread and butter, adding fractions with different denominators. Okay? So, fundamentals. We can't add them until they have the same denominator. So, let's get them to be the same denominator. 4 and the 3 is the only thing you're thinking of. You're thinking of the next number that 4 and 3 go into. That's going to be 12. So I'm going to change these both so that they are something over 12. Right? We're going to form equivalent fractions with the new denominator as 12. So you take each one individually now and you think, what did I do to 4 to get it to 12? I multiplied it by 3. So I have to do the same to the top. 4 times 3 gave me 12. 3 times 3 is 9 over 12. What did I do to the 3 in the second equation to get second fraction to get to 12? I've multiplied it by 4. So I'm going to need to do the same on the top and bottom on the right hand side. Times by 4, times by 4. We know that it's 12 as the denominator. 4 times 1 is 4. Now we have the same denominators and we are adding, so we can just add the top lines together and put it over 12. So it's 9 plus 4 is 13 over 12. Now I should have made this more clear yesterday, on Thursday, the last time we were here. Hold on, there's a couple of people trying to get in. I'll finish this example, then I'll let them in. I should have made it more clear that you always should leave your final answer as a mixed fraction in its simplest form. So right now this is an improper fraction, top heavy. We're always going to change it to a mixed fraction in its simplest form. So how many times is 12 going to 13? Well, that's going to be once. That would be 12 twelfths. How much is left over? 1/12. So it's 1 1/12. Right, so we've just gone through the first example, which is just a kind of bread and butter, adding 2 fractions with different denominators, form equivalent fractions with 12 as the denominator, then add them together. Next one is adding fractions that are mixed numbers and they do not have the same denominator. So first things first is when we are adding fractions, the way I teach it is to change them into improper top heavy fractions. So I would always do the conversion. So 9 times what, so sorry, it's going to be ninths on the bottom and that's going to be thirds on the bottom, because what we're doing right now is just converting it to improper. So the denominator never changes when we do that. So the numerator comes from 9 times 1 is 9 plus 2 is 11 and 3 times 2 is 6, add 1 is 7. So I've not done any equivalent fraction work yet. All I've done is converted that between a mixed number to a top heavy fraction. Okay, now is where I need to look at making my denominators match. Now I chose this specifically because so many people look at this, excuse me, look at this and they think, right, I need to change these both to 27 because it's 3 and 9 and the next number that when they multiply together, it gives me 27. That's not what we do. The only goal here is trying to get the denominators to match. I only need to multiply this fraction on the right here to get the denominators to match. 3 goes into 9, so therefore I only need to multiply this one. I couldn't do that in the previous example because 3 didn't go into 4 and 4 didn't go into 3. But in this case, I can just do 3 times 3 and do the same to the top, and that is going to form an equivalent fraction that's going to have the same denominator as the first fraction. So 11 over 9 does not change. You don't always need to multiply both of the fractions. 7 times 3 is 21, and that's over 9. Same denominators, put them together, add the top line. 11 plus 21 is 32. How many times is 9 going to 32? Well, that's going to be 3 times. That would be 27. So there's 5 9s left over. 3 and 5 9s. Okay, and the last example is one that purple level I'm hoping that you will be pushing on to today in the exercise, is when we just have a whole number taking away a fraction or taking away a mixed fraction. Actually, so yeah, I'll explain it. Yeah. Okay, do this just now, and then I'll explain in a second the different way you can do it. So write this down just now. It's 7 minus 2 1/3. And once again, I'll explain to you the way I teach it, and then in a second we'll go to the booklet and we'll look at the different way that the booklet suggests to do it. So 7 minus 2 1/3. So this looks a bit funny. That's not a fraction, that's just a whole number. So how can I subtract a fraction from just a whole number? Well, any whole number can just be turned into a fraction by putting it over 1. 7 is the same as 7 divided by 1, 7 over 1. How many times does 1 go into 7? 7 whole times. Okay, so any whole number is just that number over 1 as a fraction. And now we are going to change this into an improper top-heavy fraction. We know that it's the same one as before, so 3 times 2 is 6, add 1 is 7. So it's 7 over 1 minus 7 over 3. Now we're in the situation where, again, all I'm trying to do is get the denominators to match. So the next number that both of these will go into is 3. So actually the second one in this case doesn't have to change at all, but the first one I am going to have to multiply by 3 on the top and, and the bottom. Okay, so 7 times 3 is my new numerator here, which is 21. Now we have two fractions that we're subtracting this time, not adding, subtracting. It's going to be 3 in the bottom, and it's 21 minus 7. So that's going to be 14 over 3. All we have to do to finish is just change it into a mixed number. So how many times does 3 go into 14? That's going to be 4 whole times. That would be 12 thirds, and then that means there's 2 thirds left over. So 4 and 2 thirds. Okay, so that's kind of starting at yellow level, pushing on to purple level. Now, if I can stop there